Welcome. In this video I'm going to show you how you can perform a one sample trimmed mean test, or Yuen-Welch mean test, using Excel and my stikpetE add-in. Now this test is often done with independent samples but can also be done with a one sample. My add-in is available by going to my GitHub account, and then you can go for download. So download that file, open Excel, go for File Options, Add-ins, and click on Go. There's a small button near the bottom of that screen there. Click on Browse, go to the downloaded file, and that should install the add-in, which gives you a lot of additional functions. This test is used as an alternative for a student t-test, and instead of using the regular average, it uses a so-called trimmed average and a so-called winterized variance. There are two variations of this test, and both are available by using the add-in. I have a separate video where I show you all the steps on how to do it without any add-ins, but the add-in will save you a lot of work. I have my data in column A, and the function of interest is TS, short for test, trimmed mean, OS for one sample. It takes as input the data, but please do not select an entire column. Really specify the range, and it should be a vertical range. Then you can set the hypothesized mean. So in this case I'm going to test if the average age might be 50 in the population. If you do not specify it, it will use the mid-range, which is the minimum plus the maximum divided by 2. You can set a trim proportion. That's the trim proportion for the total amount to trim. So if you're using, for example, the default of 0.1, that's 10%. So that means it will trim 5% from each side. As mentioned, there are two variations. One is the UN version, which is actually also found in Tukey and McLaughlin, and a Wilcox version. And we can simply actually now use the test. I set up the hypothesized mean, type in the function, select the range. I'm using a semicolon, but you could actually also use a comma depending on which system you're using. So it's either a semicolon to separate parameters or a comma, and then select the hypothesized mean. So in this case I'm then getting all of this as a result. As you might notice, it gives a small range result, so be careful with that. It shows the trimmed mean that was used in the calculations, the hypothesized mean, the standard error, the t-statistic value, the degrees of freedom, the p-value. This e minus 07 is actually indicating that I should divide this 1.1 by 10 to the power of 7, so 0.0000, lots of zeros and then 1. So, and this is usually also the most important value. If this is below a predefined threshold, usually 0.05, we would reject the null hypothesis. So in this case, that the average age in the population is 50, and therefore claim that it isn't if it's below that threshold. Now usually the threshold is 0.05, so this is far below it, so we would reject it, and therefore there's a significant result. If it's below, we call it significant, and then we would say the average age in the population is significantly different from 50. You could also actually use that Wilcoxon, and as you might notice, that gives a slightly different result in my statistic, because there's a slightly different result in my standard error. But eventually the p-value in this case, the difference is so small that in this case we don't even see a difference. Alright, I hope this video was helpful, and thank you for watching.